Hello everyone, I'm back with another interesting problem on InterviewBit called Maximum Unsorted Subarray. This is Algo Conqueror. Let's get started. Take a minute to read the problem. We are given an array of a non-negative integers of size n. Find the minimum subarray in that array such that if we sort that subarray, the whole array gets sorted. This is basically the problem. I don't know why they named the question as Maximum Unsorted Subarray. It should have been the minimum unsorted subarray. So let's take an example. Let's assume that we are given with an array 1, 3, 2, 4, 5. So we have to find the minimum subarray, minimum length subarray, such that if we sort that subarray, the whole array gets sorted. In this case, we could have sorted this array to make it sorted, or we also could have sorted this array to make the array sorted. So comparatively from the both of them, the 3, 2 subarray is the minimum length subarray. So we just have to sort this subarray in order to sort the whole subarray. We can directly sort the whole array itself to sort the array, but that's not the minimum array. So we have to find the minimum subarray such that if we sort it, the whole array gets sorted. In this case, the answer is 1, 2. Sorry. In this case, the answer is 1, 2. These are the indices. If we sort the array from 1 to 2, then the whole array gets sorted. This is basically the problem. Let's look at another example. So this is the array. From the first 3 indices are already sorted, and the last 4 indices are also already sorted. If we sort this subarray, we will make the whole array sorted. So in this case, the answer will be 0, 1, 2, 3, 4, 5, 6, 7. The answer will be 3, 7. So this is the problem, guys. How do you solve it? I don't think there is any brute force way to solve this problem. Let's directly jump into this solution. So we are given with an array. Let's generalize this problem. Let's assume that the first part is sorted and the last part is also sorted, and the middle one is unsorted. Now, do you agree with this? The elements of sorted one less than elements in unsorted less than elements in sorted 2. Because if we sort this part, then the whole array should be sorted, right? So by default, sorted 2 must be greater than sorted 1, and sorted 2 must also be greater than unsorted. So that's the problem. Now let's look at how to solve it. Take a look at the condition 1, which states that ARR of I greater than minimum of right. What does it mean? If we take an I, if it is greater than the minimum from the right side of it, when can this condition be true? Can this condition be true for this sorted one subarray? Think about it. X4 is less than all the elements towards its right. So X4 cannot satisfy condition 1. Similarly, X3 is also less than all elements towards its right. So it can also not satisfy the condition 1. Now let's look at the sorted 2. Can X10 satisfy the condition 1? X10 is less than elements towards its right because it is sorted. So extend can also not satisfy the condition 1. Then which elements in this array will satisfy the condition 1? The element which is in unsorted array, only these elements can satisfy this condition 1. So if I find the leftmost element in this unsorted array that satisfies the condition 1, then can I say that I got my I, the left part of the result? The leftmost index that satisfies the condition 1 will fetch me the start of our answer. Let's assume our answer is start and end. Then we can get start by finding the leftmost index in the given array that satisfies condition 1. That's about the start, and now let's look at the end. Now take a look at condition 2. Condition 2 states that ARR of I less than max left. Now when can this be true? Can this be true in any of the element of sorted 1? If we take an element x1, it will definitely be greater than elements towards its left because the sorted 1 is sorted. If we take an element from sorted 2, let's take x12. x12 will be definitely greater than elements towards its right. Take a look at this condition. Elements in sorted 1 less than elements in sorted 2 less than elements in unsorted less than elements in sorted 2. So none of the elements from sorted 1 and sorted 2 cannot satisfy condition 2. Now which part of the array will satisfy this condition 2? Some element from the unsorted, right? So if you find the rightmost element in the given array that satisfies condition 2 will be our end. So by this we can find I and j of the result. I think it's better to dry run once. If you could not understand the explanation, don't worry. When I dry run this, everything will be clear to you. Now let's take the condition 2 and traverse the array from the left and track the max left variable and the rightmost index which satisfies this condition will be our end. So let's try run this. We are at 0 indexed initially and max left is initialized to the minimum value of integer. Now let's check. Is the current element less than max left? No, it's not. So we ignore this and move forward. So I'm moving the pointer forward. So the pointer is here now. Now let's check again. And we also have to update the max left variable. As the previous index was greater than the max left, I am updating it. So the max left now became 1. Now check again. Is the current element less than max left? No, it's not. So we move forward. The pointer is here now and we update the max as the current element is greater than max left. So max left now becomes 2. Now check. Is the current element less than max? No, it's not. So we move forward and we update the max. Is the current element No, it's not. So we move forward and we update the max. So 6 not less than 6 is less than max left. Now you see 6 is less than max left. The condition is satisfied. So we will update our end. End now becomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. End now becomes 4. So we got one index that satisfies the condition 2. We move forward and update the result, update the max left. As 6 is less than max left, we don't change it. Now, is the current element less than max left? No, it's not. So we'll move forward and we update the max as 8 is greater than 7. Now, is the current element less than max left? Yes, it is. So we will update the end. End now becomes 6 and max won't change as 5 is less than 8. Now we'll move forward. Is 4 less than 8? Yes, it is. So we will update the end to 7 and max left won't change as 4 is less than 8 and we will move forward. Now, is 9 less than 8? No, it's not. So we will move forward and update the max left. Now, is 10 less than 9? No, it's not. So we'll move forward. Is 12 less than, and we update max. Is 12 less than 10? No, it's not. We'll move forward. Update max and we reach the end of the array. And if you see, we have stored 7 at the end. And if you carefully see, this was our end and that's what we got after the dry run. So similarly, if you try to do it for condition 1, which is ARR of I greater than min right, and you traverse the array from the right side to left. You do the same process, maintain a variable called min right, and you will end up with the start. That's how you get the start and end indices of our problem, our main minimum subarray that has to be sorted. So this was the approach, guys. Please do share and subscribe if you liked the video. Thank you very much.